Hey, what's up everybody? Welcome back to another 3D Hangouts. I'm Noe, designer here at Adafruit. Joining me every week is this guy.
What's going on, everybody? I'm Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D print projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing and DIY electronics to make inspirational projects on a weekly basis.
Yes.
Yeah, so let's get started with this week. This week's coupon code is Gemma Jewel. So nice, Gemma Jewel.
Yeah, it'll get you 10% off.
They were made for each other. 10% off your order if you buy something today and you use Gemma Jewel. And check out, you get 10% off. Works with all the things, not just 3D printing things, but all the things, except for gift certificates and the Ada box because of reasons. But we also have some awesome deals. If you spend lots of money, you spend $200 or more, and if you're in the States, you get free shipping. Free UPS shipping continental. Good stuff. If you're in New York City, you can take advantage of our same-day delivery. So if you order it before noon Eastern time, you can have your Adafruit thing the same day. That's crazy. I don't think Amazon does that.
I don't think so either.
No.
Although they might start doing that with the drone delivery.
Drones, yeah. Well, that's kind of it. Thank you guys so much for joining us. No, I'm not editing the show. I'm just kidding. Welcome everybody in the chat room. Thank you so much. This is live streaming. It is Wednesday, episode 132, the episode that will go down as the episode. we had quite a bit of problems, but let's go ahead and get started with this week's project. I got a new slide. Woohoo! This was the reason why we were lagging. No, I'm just kidding. But that's what happened. This week's project is a Gemma Jewel. What's the Gemma Jewel? It's this guy.
Sounds right from Logan's run. This is the, this is the wrong one. It's super bright.
Oh, that shows you that you can have many different colors. Yeah, so we have two different circuits here. Well, they're the same circuit, just two different builds of it. This is cool. So this was kind of this is one of those kind of random ideas that Phil has. He's like, hey, you guys can totally make this. And we're like, yes, we could. So the kind of goal was to kind of, how do you get a Gemma Jewel, that circuit, kind of in the smallest way possible, right? Self-powered. So you need a battery and a way to turn it on and off. So we have our lovely slide switch JST adapter that plugs into the battery and plugs into the Gemma, because the Gemma has an onboard JST. And the cool thing about this is it's just kind of all sandwiched in perfectly in this kind of case. I don't think we can get it any thinner than this, especially when you want to have the battery, the Gemma, and the Jewel all in one spot. Yeah, this is kind of the smallest we can get it. And that was really kind of the goal, to kind of showcase how small you can get this thing.
Looking at my notes here.
Okay,
so
just the whole streaming thing threw you off.
Yeah,
I'll try my best to
kind
of, I'm sorry, I'll try my best though.
So obviously cosplay element you can use for a number of different costumes that involve having to sandwich an LED inside of an enclosure. One of the coolest things is you can clearly see how far away you need to make an object to completely diffuse the LEDs on there. But if you wanted to have this as a transparent item, you can see it's about 0.5 millimeters if you do want to have that transparency on there. And it's about 5 millimeters tall if you want to completely diffuse it. So the other thing, let me look at my notes here, is we're using medical tape to attach this to your hand. So before, when I was still modeling this, I wanted to have like a strap or something, a Ninja Flex that would attach to your body, but that would completely take away from the illusion of having it completely just on your body. And one of the other cooler things that we discovered when printing this out is that the tape actually sticks a lot better to a bottom surface that has been printed with a glass plate. So you can see the shiny nature of printing on a glass bottom there. It gives you a nice like melted,
it's a
shiny,
glossy surface. So it's really great for
adhesives to attach to. So I tried this a couple times, just having two bottoms, one that was printed in blue tape, so it would give you more of a rough texture, and one with the glass plate, and just taking, just pulling them apart and see where the tape will stick to. And every single time I tested this out, it always stayed on the glossy surface. I was able to adhere to it a lot more better. So there's a nice little tip for you guys. If you need to adhere something, use a glass plate with heat, and that'll give you a much better surface area to adhere adhesives to it.
Right.
The other cool thing is, like you were saying before, is that we have a twisty top to have this together instead of having a press fit enclosure.
This is great.
Works a lot more better.
Yeah, we're gonna take a deep dive look at different approaches on how to design and incorporate these in some project ideas too. So I really love me some coils. I've done like 2 or 3 tutorials on using coils in your project. Definitely a lot better than using the thread feature in Fusion 360 because coils allows you to just kind of make a custom thread. So we'll take a look at that. But I think right now we should take a deep dive into the guide. Is that cool?
Right, let's check it out.
All right, so this week's project, of course, comes with a guide, step by step. That's how we roll here. And I click on that button there. Whee! So check it out. Is that correct? Yeah, that's correct. Yeah, so the first page always talks about all the parts, any prerequisites, project inspiration type of stuff. So, of course, this is from Logan's Run, which is that movie that's from 1976. It kind of predates Star Wars. Pretty interesting. You can look into that if you want more kind of pop culture references to it. As far as prerequisite guides go, we always throw in Colin's soldering tutorial. So if you want to learn the basics of soldering, you should check out that tutorial. We also have setting up the Gemma so that you can get that so you can get the kind of board profile installed in your Arduino installation. And then of course the DIY slide switches was a project 2 weeks ago. So if you want more kind of granular steps on how to build your JST adapter, you can check that out. This guide kind of covers it a little bit. Just a couple parts to build this. All the usual suspects to build your slide switch JST adapter, the JST extension, the slide switch, and the female JST connector. But really the kind of stars of the show that makes this thing work is the Gemma and the Joule, hence why it's the coupon code, and a small little LiPo battery. So what's cool about the LiPo battery is that it's 150 milliamps, but it's rectangular, so it fits right within the kind of boundary box of a Gemma, which is nice. So how small can I get this again? You want to pick a bright battery for the right size, and that kind of dictates how big the enclosure is going to be. And then some tools, of course, all the tools that go with soldering irons and things. So check all that out. Everything's in the sidebar as well too. The next page talks about the 3D printing aspect of it. So we did want to make a point here about having the topper split into 2 pieces, mainly kind of to save on support material. So if you were to print this topper piece as one whole entity, one whole solid, you would definitely need some support material. But to kind of optimize it for 3D printing, just cut the 2 in half.
Yeah, that's a nice little tip that I don't know of a lot of people know about. When you have threads and you don't want to have any supporting materials on there that could potentially damage the geometry with having to remove the PVA supports off of that, or just regular supports off of it. It can mess with you. You don't want to have to print the threads downwards on the bed. You want to be able to print it upside down. And the quickest way to do that is just chop it off. A lot easier to attach this together because it's just a circular enclosure, so it's pretty easy to line back up because all of the parts are just mirrored to the X and Y. So it's pretty easy to just line these up after you've applied a couple drops of super glue on there to adhere that together, and that'll ensure that you're able to print the threads upwards on the bed.
Yeah.
Continue on that one.
Okay.
Next tip is on the wall thickness. Again, we always have to update our nozzle extrusion width. In this case, because I was trying to make sure that we could have thin but strong walls, we're using a 0.4 millimeter nozzle for this, but we're changing the nozzle diameter down to 0.3 millimeters with the extrusion width of 0.32. And this will give us the ability to print a lot more efficiently in terms of having a thinner, stronger wall thickness on the inside. So if you take a look at the guide, it'll show you how to turn on the wall behavior. For thin walls. So you can have, there's actually 4 perimeters for this. It's only a 1.4 millimeter width. Thickness. And we're still able to have all the perimeters inside there with no gaps. And it's nice and strong.
Yeah, the goal here is when you're playing with your nozzle diameter, your extrusion width, is to just get optimized tool path, right? So making sure that your tool is just kind of making expected geometry. There you go. Cool. And then it's really easy to glue these two pieces together. You can just use crazy glue.
You just need like
glue.
a couple drops in the center and then all around the circle, and that should adhere it very nicely.
Yeah. Okay. Next page is the circuit diagram. So very, very simple circuit. Just 3 connections to connect the NeoPixel. So you got data in, power and ground.
One point to spell out is that the connections are going through the back of both of the boards. So they're being joined back to backs to optimize the size of the entire circuit once you put it inside the enclosure.
Yeah,
just keep that in mind.
And yeah, keep that in mind. You know, this is a circuit diagram to showcase the connections, not really how they're going to be in real life. You kind of get that in the assembly part. The next part talks about the code. This is a piece of code that was written by Tony DeCola. So this uses nonlinear interpolation to fade 2 colors or more colors to do kind of a gradient fade between 2 different colors, so you can kind of add more colors as you want. If you scroll down here to the gradient, right here at the bottom where the loop is, you can add as many as these animation gradient fill functions as you want. And you can, the first color is this 3. These are just RGB values. You could probably adapt this for RGBW, but for now it's just for RGB NeoPixels. So it starts off with a 10% red, and then a full color red, and then it goes from full color red back down to 10% of a, not percent, but the value 10. So really dim red. So you can play with this and mix the different colors, very specific colors, and then the timing of it, like how the duration between the 2 colors is done by a delay, which is over here. It's 500. It's kind of like the 4th value here. So it's set up pretty nice. You can reuse this as much as you want, and you just kind of change the number of pixels, the pin that it's connected to, and then add the colors that you want. It's just pretty nice.
Yeah, which in this case, for the pin number, we just made it what was closer to power and ground.
Yeah.
So always got to think about that when you're wiring your connections together.
That's a good point. Oh. All right, and then the assembly part of the guide talks about how to build. This section covers building the slide switch, so it's kind of a specific length that you need, so we got all that in there, and it's kind of right angled, so instead of
you got to chop the pins on the slide switch pretty
short,
thin to make sure that it all fits in there, so you don't want to poke the battery because it is pretty snug inside of the enclosure.
That's right. Silicone coated wires, definitely. These are 26 gauge wires. They work really well here.
So these are the thicker ones.
Yeah.
And the reason we use that is because of the way that we're bending both the board backs onto each other. Just wanted to make sure that they were they didn't get any wear and tear in terms of folding those 2 together. As
you're soldering together, it's a good idea to kind of have them close together and secured. Having this free floating on the table probably would give you some heartaches, so I definitely recommend the third helping hands.
I mean, you could tack them down.
2 third helping
hands. You could tack or tape these down, but it's going to be a lot more easier to just have these
It's
on.
easier to have them suspended,
Exactly.
And then you have kind of a little bit of clearance off your work surface. So I hope that is a good tip for you guys. Circuit sandwich, that's what we're making here. So when you press them together and you flip over the gemma, they don't touch, because the wires are kind of holding them, so you don't have to worry about putting Kapton tape or bridging or anything like that, because the wire gives it enough kind of clearance that you need.
Yeah, there's a nice little cushion between both boards on there.
And again, this project is all kind of dependent on how kind of close can we get these components together. So that's why they're short wires in close proximity with each other. Installing the slide switch, we always use kind of this like 3-wall approach, where these walls kind of hold the switch in place. You do have access to the actuator, so there's a little cutout on the side of the case so you can turn it on and off. Install the battery on top of that switch, and then install the circuit on top of the battery. So everything that keeps this together is that twisty top. These GIFs aren't loading for me, so I have to go over here. So the twisty top is awesome. It really does hold everything together. It gives it that extra fit that you need, but it's not too tight. So you get 0 shaking in there. So there's like really no wiggle room. It's really optimized for like everything, all the layers that come together really are kind of solidified with this twist top.
Yeah, the clearance of the LEDs, everything from the thickness of the wires, it's all accommodated for inside the size of the enclosure bottom there.
Exactly.
And then the way to attach this, we've already talked about this before, it is transport, very handy little medical grade tape that can be used for like bandages and things like that. But in this case, it acts as a very lovely way to attach 3D printed parts to your body.
I think it's meant to like hold like IV tubes and stuff like that to your skin.
Yes,
that's what it's for. There's also Tegaderm tape, which is like this big strip. But John Park has tried it, and Naomi Wu has tried it too on EL wire. So if you're trying to get some things attached to your skin, Tegaderm, medical tape, any of the type of medical tape
should work.
Yeah, it should work.
And again, you want to use a heated bed with glass, so we can have a nice smooth bottom.
Sure. For
adhering a little bit more better.
Yeah. So the main hero of the show, the jewel, is there's so many different types of jewels. So they come in RGBW flavor, and then the RGBWs have 3 different types. There's a neutral, there's a cool, and then there's a white, and that's just kind of an easy way to say what temperature, the color temperature. So is it more blue or is it more yellow? So there's a dedicated white LED in the RGBW type, but we're using the regular RGBW type. So there you go. The Gemma Jewel, unfortunately, is out of stock right now, but we're working hard to make them. It does have an on and off switch built in. The JST connector is built in. Very, very great for just kind of lighting something up. Maybe we can have an extra circuit on there. So there's what, 3 GPIO? Yeah, there's 3 GPIOs on it. So very, very bite-sized, very small and compact. So it was great for this project.
There's 4. So
that's not GPIO. That's 3
sorry.
volts. There's only 3.
So I think I know why it's out of stock. I think the M0 one might be coming out soon. So.
Oh, okay, cool. Yeah, CircuitPython. That's great. You could use a trinket, but because of its circular nature, this worked out really well. Right? Were you going to use a trinket first? But the Gemma was just circular and made sense?
Yeah. Okay. I don't think I even tried prototyping it with the trinket at all. It's all just Gemma from there, just because of the circular nature of it.
And it has really big pads, so if you're looking to kind of prototype something, you could put some alligator clips on it. Nice big sew tabs as well. I mean, it's meant to be wearable, but it works well.
You could totally use add sew tabs to the bottom enclosure of this.
I like it because it just has the JST connector built into it. Because the trinket doesn't, you have to kind of solder it in. So
yeah, if you wanted to like print part of this in NinjaFlex and then swap out your filament and then add the PLA on the top so the threads will work, you could totally do that as well. That should work.
NinjaFlex? For what? For wearables?
Yeah. So if you wanted to have like half of this enclosure be NinjaFlex, so you could have the little sew tabs on there.
Okay.
So you could do that and then swap out the filament halfway through or about like 30 millimeters up and then swap it up for PLA.
Yeah, that's going to be a really good option if you have a curvature that you need to mount it to, something that has a nice curve. NinjaFlex might be the way to go.
Yeah.
Cool.
Oh, and Kirby's pointing out that DigiKey does have the Gemmas in stock, so if you guys do want to pick these up,
you could always go to a different distributor.
Jump over to DigiKey.
So that's who bought them all up, huh? DigiKey. Great. All right. Well, that's
pretty much it.
That's the project. Yeah. There's not much to it. There's really kind of a reason behind it being really, really simple. Mainly because I think it's great for people that are
for other projects.
I think it's great for people that haven't done any soldering, any electronics at all. I'm really hoping that the cosplay community sees this and starts thinking about how to incorporate it into their work. You don't have to have it in this way. We actually have quite a few different projects that use the same circuit, and even twisty tops as a means to connect parts together. So what I'll do now is just kind of show you some other projects that use coils, and then we'll jump into the CAD stuff, which is fun, my favorite part. So let's take a look back at the website. Check this out. Well, not that one, not that one, not that one yet. This one. So this is a hammer that I put together. It has sound effects and lights and stuff. Using coils, I was able to kind of make these, the neck of the hammer, the base of the hammer, all have threads using coils. So you can just screw them together, and they all have end stoppers so that they tightly stay locked together. And this is a really nice approach because I don't have to really glue them together. I just kind of twist them up. So really neat approach to using coils. Another one is our mace. So the handle, the pommel, and the icosahedron mace part are all twisty threads, so that you just twist them all together. I really like that approach. It worked really well here. Another one is this interesting storage twisty top. Again, 3 for the topper, it just twists on top. These are kind of bigger. So what's cool about that is you can kind of make them as big as you want, or small. I think you can go down to like 2 millimeters. We'll take a closer look at that. I used them in this project. These are like little NeoPixel enclosures for my headphones. So the topper, it's basically this type of enclosure. You just kind of twist it on top. This is the same thing, just not on the headphones. Mainly kind of stores a square board and the 24 NeoPixel ring. So that's another great kind of basic use of it. I think that's it.
Yeah, I think what this really highlights is that you can use pretty much the same enclosure and threading mechanism to make a whole bunch of completely different projects.
Right, and then this one showcases kind of like they don't need to be circulars. Like look at the hammer; it's a square, but you can have a cutout that's a circle, and then use it
you can
that
also
way.
hide it too by having the threaded circular part that goes into the thread and has the square component.
That's right.
Screw it all the way up top to it to hide the circular threads.
That's correct. You can see the threads there, all nice and thready like. So let's go ahead and jump into Fusion and then take a look at kind of how this thread is. This is a little bit different, which is kind of a nice approach to it. But here it is in Fusion. This is, of course, free to download, and you can modify the original solids and things. So let's do a section analysis and take a look at what's inside here. You can see that there is a coil wrapped around here. So actually, let me turn off the section analysis and then look at just the topper. So here's the kind of topper piece. The coil is actually the lip, right? So this coil wraps around and is inset a little bit inside this little topper piece. And then instead of using 2 coils, you can just use that one coil to make a kind of cutout
tool for it.
So you can see that it's been used as a cutout tool. So this enclosure is a little bit thicker to accommodate for that extra material that's being cut away. So you can see how it kind of wraps around. And the important thing that you have to kind of look at is the placement of your coil. So you can see that the top of it kind of starts here. So you have sort of an area to kind of allow the threading to kind of come into. So that's really important to have there. Because if you had this positioned even lower, then the coil wouldn't even be able to get in there because the cutout starts at a later position.
That's one note I want to point out, highlight, is that when you create your threads, you have to move it up in the Z so that you can have the coil start right at the top there. Otherwise, you're not going to be able to even get that in there.
Yeah, you can see kind of how it cuts in there. Maybe this is better here. Kind of how it feeds into it right there at the top there, so that you have that kind of opening there. So that's how that happens. So you just move it around. Real quick, coils.
So if you turn on the coil reference, I want to say, yeah, that's what I actually built the coil out of. And then from there, I had to move it upwards on the Z so that the coils will start right at the beginning of that.
Okay.
So you always want to make it a little bit more taller to accommodate for where the threads will start at the beginning of the enclosure top.
Okay.
Because otherwise it's going to start like underneath there, and then you can't get the thread to even start.
Exactly. So I have something here that kind of showcases a different approach to it, and that's using 2 coils that kind of they kind of wind into each other. So you can see this cross section here, how they're opening. The only kind of downside is that you kind of need a little bit more gap. You can see there's a large gap from here to here, and that's just to accommodate for the actual thickness of the size of the section of the coil. So you can see how that's working there. So you have a coil on this height, and then you have another coil that's kind of moved down and rotated at 180 degrees so that they kind of meet with each other. But a thing about that is that you can kind of have it start at any position within the enclosure, if that makes sense. You can kind of have it positioned not just in the top, but in the center of your enclosure if you wanted to. So there's different approaches to kind of achieve the same goal. It really depends on your components and what you're trying to accomplish with it. I think I use this method more just because I didn't have to worry about such a small enclosure, but you do see that gap. So, and you do want a little bit of clearancy. You can see how there's about a 0.5 millimeter clearance.
I think I got away with 0.4.
0.4, I think, was the
clearance
number.
for mine.
Yeah. So as long as you have some clearance there, you should be pretty good.
And one thing to point out too with mine, I used the threads as a cutting tool, and then I clicked on all the faces inside there and pushed them in.
Oh yeah. So you just did an offset.
An offset on it.
Nice.
Yeah.
I think
I don't have to do
one of these guys.
Yeah, just so I don't have to make a separate set of
absolutely, yeah, coils.
Threads.
No, that's
coils.
a smart way to do it. I can see you did it here, which is great. Yeah, you can just do that. And Fusion's smart enough to kind of push everything out.
Yeah. Another thing you also want to do is you want to make sure that the threads the diameter is small enough to allow for the top part.
Oh, yeah.
So you can have it overlap. Not overlap, but it's as big as the enclosure. This little part right here is what I'm talking about. The face right there.
The outer
just
edge
click
of
on
it,
it.
right?
Yeah.
Yeah, this guy here.
No, this
this
here.
guy?
Yeah. So you just want to make sure that the thread is smaller than your outer diameter that's going to hide.
Because they're flush with each other if you look at them.
Exactly, yeah.
See how they're flush right here. From here to here, this is the same. Interesting. Very cool. So there's just two different approaches to kind of get coils in your project. Real quick, I'll take a look at what kind of options you have in a coil. You have the ability to tell it which rotation to go. So if you want to be counterclockwise, this would work really well if you were doing something like pedals for a bike, because they actually have threads on the other side so they don't unscrew themselves. You have the ability to change the diameter, of course, the height, which is like the overall height of the coil. The angle of the coil. You can use coils for everything. I made a unicorn horn with this coil using the taper, just cool. You have a couple options for sections, so you can do circular, square, but really the triangle one is what you want to do to make these custom threads.
Because it has those nice little stops at the end of that.
Exactly, and they're chamfered already. So you got the ability to change the position of the section. That's the actual coil piece. So inside or on the center and the outside of your given diameter, and then the section size. I found 2 millimeters to be like the smallest you can get it. So this works well. If you're probably doing something with SLA, you could probably get smaller. I don't know. I haven't tried that. And then of course you can change the operation. You want a new body, cut, all that sort of stuff. So that's it. That's kind of a quick crash course on on coils.
Super useful, super handy. Nice way to close your enclosure.
Close the enclosure. Where am I? I'm here. Gemma Jewel. That was fun.
Save 10% off on your order.
10%. Cool.
Expires at 11:59 p.m. tonight. Works on 3D printers, material, and of course all of the lovely electronic boards that bring your projects to life.
They sure do. Do you want to move into what are you prototyping?
I think that's it.
Yeah. So check out Gemma Jewel project. I forget what we call it. Logan runs life clock.
Yes, Alpha X signal saying that threads can be a little tricky.
Yeah, just the positioning. Sometimes you need end stops. That's why I have tutorials. Please check out in the links below. I'll have my links to 2 of the tutorials on how you can use really steps through the steps, right? Step by step. Hey, look at this. This is really fun. So last week we were showing you guys the Joy Bonnet. This is a Raspberry Pi hat that Lamar designed. She designed it live on her show, actually. Remember? It was awesome. So it's basically a little add-on for your Raspberry Pi that has an analog joystick and a couple of buttons. So this is made for the Raspberry Pi Zero or Raspberry Pi Zero W. And what I wanted to do here is make kind of have an excuse to dive into CNC milling more. So I milled this out of 2 different pieces of wood using the Other Mill, which is a CNC desktop machine. And I use Fusion 360 to create the design and to make the tooling strategies. So kind of telling what operations and how it should mill. So what's cool about these is these aren't really secured. The thing that's holding these two together is just the headers themselves. So you can see that I have 2 machine screws that are holding this to some standoffs, right? And the same thing here. There's a little bit of cutouts here when you're CNCing, and it, you could do undercuts, but for this one I didn't do undercuts because I didn't want to have to flip it up here and then start drilling out these holes here. So this worked out well. I think I used like 2 or 3 different tools to do this. These are the flat end mills, and the way the enclosure is kind of held together is just these 2 here. They're low profile headers here. These are surface mounted on the board itself. These I wouldn't recommend soldering them in backwards like I did here. I would kind of trim them short because this is kind of the shortest I can get it. You probably could get it a little bit shorter if you were to kind of remove this plastic here or solder it from the bottom so that you get this really thin thing, but it's up to you. That's it now. So what I wanted to do is kind of do a quick play test. So what I'll do is I'll use a monitor here. So this is really cool. This is our 5-inch HDMI backpack, and we 3D printed this enclosure for it. And what's cool about this is that it has a battery. So this is a battery holder, one of the battery holders that we carry. This is soldered to a UBIC, so it takes the 7 volts from this battery and it downsteps it to 5 volts. So I got this really nice monitor.
Again, just to illustrate what we mean by battery holder, we sell a couple different ones. This is for the Canon. We have one for Nikon, one for Sony, and they have these little, take this off here, these little pads you can solder to that will connect to the Canon batteries. So you can grab power out here, and you can use something like a UBIC to step the voltage down if you need.
Yeah.
That's what we're using it to power this guy here.
That's right. So it works really well with the Raspberry Pi. It's got a screen resolution of 800 by 480 or something like that, which is kind of small, but I think it works well for this project. So the only kind of thing you have to worry about is kind of wire management here. So I do have 2 wires here. There is no battery in here, so you do need some sort of power. So this is just plugged into my USB hub. And then this is a HDMI regular. And then this little white piece here is actually a mini to regular HDMI. So that's how that's working. And it's pretty nice. I really like the Raspberry Pi Zero W because it does have the right Wi-Fi. So I didn't have to plug in another hub and then a keyboard and then a mouse and then the Wi-Fi dongle.
And then you run out of
yeah,
USB
then you
ports.
run out of USB ports. So this works pretty well. It is very, very small, so you definitely want a case for your little Raspberry Pi here. So I don't really want to play anything because I'm gonna suck.
Because you're looking at the monitor.
Yeah. Is that Kirby? Where's Kirby's adventure? Do you see it? I don't see it. Is it this one? Can't tell. Where's Kirby?
Second one down, yeah.
This one?
Yep.
Okay. Cool. So there's no audio coming out of this, so if you wanted to do audio, you'd have to plug in a USB audio adapter, so you're just adding more stuff to it. And I think the end goal is to kind of make this portable, really, really portable, where you don't need power here or HDMI here. That's requires quite a bit of kind of planning and maybe some hackery, but this is kind of the use case that it's intended for, right? So as far as ergonomics goes, it can be a little bit, your arms can kind of get a little cramped if you're playing too long, but hey, this is the smallest we could get it, and I think that's kind of nice. I don't know what I'm doing here. Yeah, so this was fun. I posted this on Instagram, and quite a few people liked it, so this is kind of fun. Is it light? No, it's not light. I just don't know what I'm doing. I like Kirby. Both the person and the game. Anyway, this is a lot of fun. If you want to pick up your Joy Bonnet, I would sign up for the email notification, but then I would also kind of camp out on the website, just hit refresh every day. That's what we do. That's our pro tip. Just go on the website and just refresh every day. That's all. No big deal. It's fun. Yeah, so the software that's running this obviously is RetroPie. Phil B wrote some special scripts to basically turn this into a USB keyboard, so that's what RetroPie sees it as, a USB keyboard. Yeah. So that's how it works. Did you shut it down?
No, I'm certain Mario.
Okay. Q. That's a lot of fun. So let me look through, while you play that, let me run through some of the things as far as notes go. So I will be working on a guide and a project video. I think there's a lot to kind of gain here from a CNC milling perspective, like how do we set this up, some things to think about, like material, prepping your material, the wood itself, how you should how the grain of wood is a certain orientation, and you want to optimize your toolpaths for the material. Yeah,
there's so much more thought that has to go into
really
making a project with.
Right, and I'm still learning myself. I don't really fully know how to optimize my tooling strategies yet, so I'm learning that as I go. Some mistakes that I learned is the PCBs actually don't line up. So in Fusion 360, I have the mounting holes for the two PCBs perfectly aligned with each other and lined up.
We're still a little bit off.
In real life, they're slightly off a little bit. So I'm not sure. I guess it's because of the position that the female headers or the male headers are soldered in. So they're not exactly lined up with the board holes. So it's slightly off. Another thing I noticed is that the standoffs are too kind of short. So what happens is if you squeeze like a certain angle of the enclosure, it kind of triggers some of the buttons. So you can see here. Are you clicking it? Yeah, that one. You can hear that click. So it's actually hitting A. Another thing is I didn't really break out the shoulder button, so there's no shoulder buttons. I just didn't like the look of them, so I just didn't make holes for them. So I don't really use them that much in Super Nintendo here anyway, so I think it's fine. So that's kind of it. Some other things to consider is to try to make it thinner, of course, and surface finishing for the wood. There's lots of things you can do here, spray lacquer, or mineral oil type of stuff. So there's a lot of things you can do, because right now it feels a little fuzzy, but if you add this bit of lacquer, you can make it really nice and shiny and feel a little bit better. So that's it. That's the Joy Bonnet case. Just got to put together a guide for it. So I recorded a bunch of footage of milling it and all that, so hopefully that'll work really well. You want to shut it down?
Too much fun.
Yeah, you can shut it down if you want. There's 2 buttons here to exit, and then you can just do a quit and then shut down, or not quit, emulation to be shut down system, and then it kind of safely shuts down. And I really like this screen. It's so nice. It's kind of portable. Obviously, it's portable. We use it a lot for shooting and stuff. Another thing is that I really like having a thread insert for tripods, so we can mount this to a tripod on top of your camera or whatever. And 2 switches. One switch does dimming, and the other one just kind of shuts the whole thing off. So it's really nice. So yeah, if you got a bonnet, if you were lucky enough to get one of the bonnets, definitely consider making a case for it. Maybe this could also work as a one-handed sort of joystick thing. I think that feels a lot better in your hands than this.
It really does, yeah.
It really feels nice. Wow, it's kind of warm. Touch it. The wood's warm from just playing a couple of minutes. There's enough room in there for heat dissipation. I don't think so.
No.
I mean, wood can catch fire, but I don't think it's going to go that hot, right? So anyway, that was a lot of fun.
Almost feels like a Joy
a Joy Bonnet, like a Joy. What are they called? Joy-Con?
Joy-Con, yeah.
Yeah, we call it a Joy Bonnet.
Very nice. So soon,
Very
out.
soon.
Very nice.
Yeah.
Of course, you get 3D print this as well.
Yeah, I did. I 3D printed it first just to kind of get the fit and finish right.
Yeah.
But man, CNCing is so much more accurate. I didn't have to worry about expansion of the material. So good stuff.
Very cool.
All right. So if you want to pick up any of the stuff, the screen is in stock. You can pick up the screen.
The battery holder, of course, all the wires, solder. Tools.
Here it is. Check this out. Right here, we have a full guide on how to build the screen. Not very difficult.
Yep, there's the U-BIC that is doing the step down for the monitor.
We manufacture this. It's really nice. Well, it's a giant PCB, right, for the screen, which is nice. It's got mounting tabs. You can break them off if you want. They worked out really well for this project. So check it out. I think it's really cool. All right, what else we got?
Let's see.
There.
We have a really cool adaptive features using
parameters. So was it last week Saturday? I did a tutorial on how it's kind of like the lessons I learned from the Featherbox project, which was last week's project, and I wanted to kind of showcase how to do it in a more simpler way. So what I'll do this time is, instead of kind of showing that, I want to show something a little bit different. So here I have a basic project enclosure, and it's fully parametrically driven with user parameters. So take a look at the box real quick. It is a box. It has 4 standoffs, 4 mounting holes on the bottom, and you can see that there's a little bit of material that goes around it, and there's the thickness. It kind of looks like your basic run-of-the-mill project enclosure, but what's cool about this is I can quickly change this. So I'm going to open up the user parameters window, and I have a couple of them set here. So these are sort of basic, right? Length, width, height, and hole. So let's say I wanted to make this a little bit longer. Let's say make 80. So what just happened is increased the length, and the 4 corner standoffs are adaptive. They moved with the enclosure. So I can do this with the width as well. So let's say I want the 60, and it pushed it that way. Those enclosures worked really well. And I also have holes. So what happens when I type in, let's double this to 4. So you can see that not only did the holes update, but the standoff, the material around the hole, updated as well. Well, what happens when I make it taller, right? So let's make this double, 20. You'll notice that the standoffs have also updated. So this is really cool. So let's first talk about how the standoffs are set up. If I go into this sketch here, this will kind of show you how those standoffs are set up. So actually, I kind of broke this up into 2 different sketches. So I have here is the diameter, which is basically just hole. So that it's parametric. I can tell it whatever thing I want. And then the distance from the edge of the enclosure is also hole. So that's how it's able to kind of dynamically update when you change the hole, because everything kind of is driven with that one user parameter. So that's the hole. Well, how about the standoffs? The standoffs are over here. It's basically just a 2-point rectangle. And for the actual distance away from these areas, the way that the sketch is kind of set up is to just have a distance from these 2 angles here. So I double click on it. You can see it's just a little bit of math. It's basically saying the hole times 2. So always double that hole. No matter what the size is, it'll always be double that. So I will always have enough room to accommodate for that hole. Same thing with this area here. So hole times 2. That's it. And then for the height is actually set up not through a sketch, but through the extrusion. So in the extrusion, I have it set to be height divided by 2. So it'll always be half of the height of the enclosure, no matter what it is. It'll always be 2, or half of the thing. So this is an interesting way to kind of make an enclosure that's parametrically driven with user parameters. I think there's a lot of opportunities to use this in projects that kind of really need it. So check out my tutorial if you want to know kind of the full details on how to set it up in a more simpler way. But I just wanted to do this example in the morning just to kind of see how would I go about doing it. And I was able to do it with just a handful of features here. Obviously, I could optimize these here probably a little bit better, but hey, I think it's pretty good. So I have that saved out. If you guys want this, I will share the public link with you. But that's pretty much it. Adaptive features via user parameters, I think, is a really powerful way to make parametric models. So that's kind of it. I'll have the link to the tutorial and the project, the kind of sample project down below so you can play with that. Yeah, you can just kind of step through it, which is nice. Pedro's answering the chat room. Thank you, Pedro, for doing that.
Yeah, we're getting some invalid codes. I am emailing Jessica on this, so you can hopefully check this out before lunchtime.
Oh, really? So somebody tried the code and it didn't work. Guess what, guys? Later tonight, there's even another coupon code. That's later tonight. New products. I would definitely get those new products as soon as they're announced, so you don't have to wait. Anyway, we have a coupon code later tonight as well, so you can check that out. I think it's time for Shop Talk.
Yes, this week's Shop Talk.
I don't know, where'd you put the birdhouse?
Oh, it's right behind me. So this week's Time-Lapse Tuesday was on this really cool Birdhouse by Brent. I forgot his name already.
Brent. He also goes by Eric J. something Wood, Dungwood. I have his website here, but let's show off the thing first. So if you check out every Tuesday, we have a time lapse, and this Tuesday is no different. We had a time lapse of the American Craftsman Bungalow Birdhouse. This was actually the winner of a 2013 design, I believe. It was back when Thingiverse and MakerBot were holding contests. I think they still do, but this came out phenomenal. So tell us a little bit about how did you print this and what kind of interesting things you learned.
Yeah, so this is set up in a couple of different pieces. I only printed 3 of them: the base, the actual house part, and the
chimney.
Chimney, yeah. So this was designed for a 0.4 millimeter nozzle, and when I looked at the calculations for how long that would take, it was like 48 hours. I only had like about a day to print this out, so I got the 0.6 millimeter nozzle on the BCN 3D Sigma. I actually used both of the Sigma printers to print this out at the same time, and it only took 10 hours, down from 48 hours.
That's crazy.
Yeah, so I'm using a 0.5 millimeter layer height for this. Printed it at 85 millimeters a second.
So fast, so it's large.
Fast and large, and you can tell because of the larger diameter filament or extrusion width.
Let's go overhead.
You can see a lot of the droopage that a 0.4 millimeter nozzle would have been able to catch, but because it's so heavy, printing so fast, you can see there is quite a bit of drooping. So you can see it right here as well. Little steps, or the rails for these steps here. You can see a lot of the droopage, and
so those are things to be aware of when you're printing high details with a larger layer height and of course the larger nozzle.
Yeah, for some reason the framing on the left side here didn't quite make it, but it turned out really perfect on the right set of windows here.
Yeah, no supports at all in this, so
absolutely
it's
no supports.
amazing.
Yeah, I just printed down like that. This was the bottom, and even though it did have a little bit of droopage, like in areas around the roof, it came out really well. Definitely would trade that off for the 10 hours of printing instead of 48 hours.
Because from afar, you're really seeing it from afar, and it looks really great and detailed as it is. Yeah. We have yet to put it up on a bird, or to get a bird in there, but we'll work on getting a bird.
Yeah,
in there.
so there are.
Holy moly!
Don't worry, this is like super.
Is it that heavy?
Yeah, it's pretty heavy. It's 680 grams, so it did use I want to say like about half of the spool.
Ouch.
And there are a couple of little slots that go into a little framing support that can attach to a pole.
That's right. Yeah.
There's also a bunch of ventilation and like holes to let like water come out.
Okay.
So very thought out. There is a lot of really good pictures on there. They're just renderings, but it shows what the inside looks like. There's a lot of space in there for a nice little bird.
Mansion for a bird.
Yeah.
That's crazy. Yeah, very, very awesome.
Excellent job on that. So he's done a bunch of really good designs. One of the other ones I remember.
J. Rosenberg.
There we go.
Check him out.
Yeah, he actually said that he's going to be doing a tutorial on how to design models that don't require support. So be on the lookout for that if you want to check out his YouTube channel.
Yeah. I think he just started his YouTube channel, so you can check him out.
I really like the little MakerBot mascot that he made.
This one or
2011? This one? Yeah, the first one. I think this was actually one of the first models that I printed out that required a bunch of parts and assembly. So it was...
Sorry, did I lose your train of thought?
No, looking at the photos of it, I wish I grabbed the one that I printed just to show it off. It comes out excellent.
It's very great.
It was a different time back then.
It was so different back then. Yeah, this was great. So check out Brent's new YouTube channel. You can check it out here. I'll have it linked down below. And there we go. There's Brent.
Yeah, a couple of other really cool designs you guys should check out. Yeah. But if you're looking for a nicely detailed birdhouse, give this one a go. Although, like I said before, you might want to use a bigger nozzle to cut down on the print time.
Yeah, this is another good example of using a big... This seems to be a reoccurring theme. Every week we're coming out like, hey, look at this giant print I made with a big nozzle. Makes sense.
Yeah.
All right.
So check it out. Cool. Bungalow Birdhouse.
All right. Shop Talk. That was Shop Talk.
Yep.
Community Makes?
This week's Community Makes. First one is...
Oh, yeah. Actually, I have one more Shop Talk thing I want to do real quick. Here's a contest. I just got this from Kirby. He actually shared this with me on Hackster.io in collaboration with Make. They're having an April Fool's 3D printing contest. Winner gets a CBNC Delta kit, the H2 Delta. And the goal of the project is to design a cup that is impossible, annoying, or tricky to drink from. April Fools, so it's kind of funny. So there's a lot of different ideas you can do here. There's specific rules, like you can't be able to drink from it. It has to spill. Like it just has to be annoying. Kind of funny, because the approach is to how to make the best functional thing. It's the exact opposite. So you're kind of straining yourself, and how do I make that fork not
the functionality that you're adding to it is to make it non-functional. Right.
It's kind of bizarre. Neat. So check it out. I'll have the link below. You have 25 days. Winner gets chicken dinner. Printer. You can print a chicken dinner.
Large Delta style printer there.
Yeah, from CNC. CNC.
Cool. Check
What's
it
up
out.
with the Oreos and toothpaste? That sounds gross.
Probably the April Fools. Give people Oreos
Ooh.
with toothpaste in it.
Wow. That's fluoride, then. It's poison. Anyway, that's fun. I got another one. PinShape is, we're doing a kind of a collaboration with PinShape, so check them out. They have this new ambassador program that's going to be released soon, and there is some opportunities to get some discounts and stuff like that. Another thing is I'm a guest blogger on their blog, so I'm going to have a blog post about using adaptive features in Fusion 360.
Come out later
so it'll come
today.
out later today, I think, but there's some great content always every week. I really want to print this thing out. This is like, they do kind of a weekly roundup of some of the designs that they really like, and this is one. It's an SD card spinner. I think as you spin it, the thing grows. Is that what's going on? The SD cards will grow?
I wish they had a GIF. I didn't
Yeah,
know that.
it's dying to be GIFed.
Wow.
This is
Okay,
great.
I'll try it out.
I love that design. I think you just kind of twist and the things kind of pop up. I think that's what happens. Great stuff. And that is all for Shop Talk.
Actually, I think there might be one more.
You got another one?
Oh no, that was Community Makes.
Yeah,
next
Community
one
Makes.
is a nice little funny one. It's a Funky Town.
Let's do the first.
keypad.
This week's Community Makes. First one is a Funky Town keypad?
Yeah.
Question mark? Where is it? There it is. This is cool. This is from Thingiverse user Joe O. Stratter. And this is kind of his tribute to a South Park character, Cowley. So anyway, it's a box with the keypad on it. It's using a little Arduino Nano, and it's using a piezo buzzer to kind of play some funky tunes. So you can watch it here. You have to have like a special key code. Let's see if it works here. Nice rocker switch. LEDs. Super cool. I think it's fun. So he has his Arduino code is shared, and also the STL files, of course, and a little bit of a circuit diagram too. This is fun.
It's great for doing memory.
Yeah, it's kind of like a game.
So if you take a look at the circuits, he's actually doing a tone generation to the piezo.
Yeah, which is great. Good stuff. So that's all there. Great project. Here's another one. This was actually sent to me on Twitter, and this is pretty funny. This is a real Google Gnome.
Yeah, so for April Fool's, Google released a funny
Formats.
little
That's great.
Google Home parody commercial for this.
Yeah, so this is awesome. It's 3D printed parts that turn your Google Assistant into a gnome. So if you were watching, 4 million people did, they saw this kind of goof ad from...
Introducing Google Gnome.
Whoa. It looks just like it. It's awesome. This one's better because it has a diffused red PLA, so you can even see. Pretty cool. I think this is really funny and really good. So check that out.
It was funny how
Lots of
fast he
fun.
was able to get this out.
Yeah, he got this up really, really fast. So shout out to you, sir. Check out his YouTube channel as well, How I Do It, which is great. And get your Google Home thing going on. Cool. Next project I wanted to share next project I want to share is just this really cool retro arcade. I've been wanting to build my own little retro arcade for a little bit. It's kind of a challenge because big pieces means a lot of stuff. This is so clean and professional looking. The back is 3D printed. I think it's a combination of like kind of hand woodworking and whatnot. Maybe not. Maybe I need to look into it more because all the pieces are here. I don't see why you can't 3D print them. They look optimized as well. I just kind of saw this and quickly posted it up on the blog and like, look at this is awesome. A lot of pieces going on here, but again, the end result is a beautiful looking MAME cabinet that's like fits right on your desk. Look at the back there. Look at all the colors and stuff. Is that Lego?
Wow,
It's beautiful.
looks like
This is beautiful, man. I don't know. I just love arcade machines. Tiny
Especially
little
ones that are super clean like this.
Right,
Awesome
so-
job, sir.
Oh, there's a full Hackaday IO project, so maybe there's more details there. Designing Tinkercad?
Wow.
My goodness. Beautiful. Beautiful, beautiful. Great job. So all the details are there if you want to build your own. Look at the Neo Geo, Amiga, PlayStation. That's so beautiful. Great job, sir. Thank you so much for sharing that. And was Christopher Tan? Great. All right. The last project I want to share is this one just came in from Sam. Him and his kid actually built a Pi Girl Pocket. So you can see here his kid's learning the basic skills of soldering and putting things together.
I think this is the perfect project to introduce kids to soldering and video games.
Yeah, it's a little challenging, so having parental parental guidance is always great. So it just makes me feel warm and fuzzy and sad when I see a parent and a child. Looking so awesome.
Successful build.
That's
there.
what's up. Very cool. Love it. Thank you so much for sharing that. And that is this week's Community Makes.
Very cool.
I need a song that goes whoosh at the end of that. Community Makes. Like
And
Adabot
now
says something.
we can jump into this week's Q&A.
Yeah. Sorry.
First question came up. Somebody was asking, will it violate their warranty if they switch the nozzle on their MakerBot Smart Extruder?
I don't know. I
Does
really don't know.
MakerBot have different nozzle sizes for their
For the
Smart Extruder?
I don't know.
What we're doing here with the Sigmas is they have a whole family of different nozzles that you can switch out for. So that's all
correct.
I'm doing. I'm not hacking anything or voiding any warranty. I'm
No,
just
it's made
swapping
for it.
out
Made by
a
them,
nozzle.
made for it. Yeah.
Yeah.
Something with the FlashForge Creator Pro, you do have to kind of unscrew. You have to heat it up, then unscrew the nozzle,
yes.
and then put the nozzle in.
Maybe that's what you're thinking.
I think most.
I did not. I don't do any unscrewing of any nozzle. The Sigmas
Just don't tell them
have.
that you did. Just if it breaks, just put the old one back and be like, I never touched it.
Yeah, they'll know if there was some.
They'll know. Sure.
Question. Started doing a dual color on their FlashForge Grid Pro, and they're getting lots of oozing. Whenever I bump up the retraction 2 millimeters and drop the extrusion, even after I bump up the retraction 2 millimeters and drop the temperature 10C, any tips or fixes? Probably an ooze shield is what's going to work out best for getting rid of any of the oozing.
Yeah. I think you can do that in Cura 2.4 now. You can do an ooze shield. A pillar, is that what it's called? A prime tower?
Yeah,
is
but
another.
for the FlashForge, just because both of the nozzles are really close to each other, and
Probably the ooze shield is the best.
the ooze shield's going to be the best because it'll catch any drippage that's on the other nozzle while the opposite one is printing or not in use.
And then there's some things you can play with, like the distance between the ooze shield and the part. You might want to play with that. The bigger the distance, the less oozing I think you'll get, but the more time it'll take.
Yeah,
There's type of balance there.
The type of ooze shield too, I think, is the one that curves around the part as well.
Okay.
So that
Forget the name of it.
you can quickly look inside Simplify.
Is it waterfall or something?
I think it is Waterfall.
Something like
That's
that?
the one that I would recommend you use. Additions, ooze.
Waterfall, yeah.
It's either Waterfall or Contoured.
Yeah. So there, it just kind of goes, it kind of tapers along with the part.
It like sort of hugs the shape around. So definitely try that.
Oh, that's right. Julio is saying that, or Jello is saying that he's using Flash Print, which is kind of, I guess FlashForge's slicer, and Cura doesn't work with the FlashForge. I don't think it does either because it uses that X3G wrapper thing for Sailfish, the firmware Sailfish, not Marlin. So, you might want to consider getting Simplify 3D. It is a little bit pricey, but it's
it'll
definitely
do
worth
some
it.
really nice dual prints on there. We also have the printing profiles if you want to use those for Simplify 3D as well. When we were doing the dual extrusion tests for the FlashForge, we were able to get pretty clean prints by using the contoured or waterfall ooze shields on that.
Okay. Next question is from Shelly Stone, who's saying, asking, do we use any kind of sensors to detect when filament's low?
No, we've seen some people have built some really good ones. There's some that are on the market, but you really should try looking into some of those. It would definitely help out in when we run out of filament.
Yeah, we've had it happen, definitely.
Tuna, who's asking about the MakerBot nozzle, says that there's this website that sells them, but MakerBot themselves has not said anything about them. Okay. So I would recommend heating up the nozzle to, I don't know, like 150 maybe, just to loosen it up. You do not want to take that nozzle off while it's cold. It will strip and it will break the nozzle off.
Ouch.
So if you do want to go in that direction, testing out different nozzles, make sure that the nozzle is heated up first. Have like tweezers or pliers that can grip onto the hot nozzle. have like a glass or somewhere where you could put the heated nozzle to let it chill for a while until it cools down.
And don't touch it with your bare hands while it's hot.
Obviously, yes. I mean, although I have done that before thinking that the nozzle was off, I had burned my tips of my fingers. So just be super careful on that.
And good luck.
What are our options about the recent very cheap 3D printers under $200, like the Moto Price Select Mini 3D printer? Yes, one of our engineers, Philip Burgess, has one and has been really impressed by the quality that you're able to get out of the
I need to ask him more about it. Like, how is it in the long run? How does it work well?
Mm-hmm. And if Phil B gave it a good review, it's probably good.
Yeah, maybe it's a hit or miss. We had the same things with lead printers.
Yeah,
but yeah.
Let's see, there was another one. What material to print without a heated bed that can handle heat in the car? PLA keeps deforming. It's not even summer. So probably, was it the PET that we were able to print without a heated bed? Just use like
PET G.
Yeah,
maybe that's the one. PET G. There's so many variants now of copolyester, nylon. It's probably another one.
I think those require heated bed though. I think it was the PET from Print Solid. I want to say
PET Plus, PET G.
I think it was just PET.
Yeah, there's definitely some opportunities for us to test that stuff. We haven't really.
No, we already tested it with doing propeller guards for drones.
Right, more for heat then. Like, how does it withstand the heat outside?
Actually, no, we did not test that. We were just testing the rigidity of it. Yeah,
kind of impact resistance. Crashing a drone into a wall for science.
So we just got an email from Jessica saying that the coupon code should be up and working. So if you guys want to test that out right now.
That was quick.
I think I had a page.
Jamma Jewel.
Did I have it open?
Jamma Jewel.
Jamma Jewel. Try that out. It should work now. I'm still looking for that PET Plus stuff that I know worked without a heated bed. Yeah, here it is. Oh, sorry, it was from Made Hackers. It is PET Plus filament. So this is what we tested out, and it worked pretty good without a heated bed.
Cool.
Again, we did not test will it deform inside of a car with heat.
Okay.
So I did not test that out, but I do remember having to print pretty hot with this.
I recommend checking out Tom's guides. Maybe I'll link it down below. He has some great reviews, like quick reviews on filament. I think it's a series called Philoween, something like that.
Oh yeah. His hashtag for all of his filament reviews.
One of his tests is he rigorously tests the heat properties by dumping a bunch of hot water on the print and seeing how much it deforms. So he has kind of his own scoring system, which is really cool. Yeah. So check that out. Great source for reviews and more nitty-gritty tech stuff.
Yes, 10% discount on the Adafruit store. Coupon should be working out. We have confirmation from Jello 3D.
Thank you so much. You're supporting the show. Woohoo. And the whole family as a whole. The Adafruit fam. Thank you guys so much. That is the way to support the show, is to just keep buying stuff, and it helps support your maker habit, and it helps us support our maker habits.
Oh, we have Bill Binko in the house.
Hey, Bill. Bill's in the house.
He's saying that PETG is remarkably flexible after printing.
Really?
Yes. So
it's not rigid and kind of...
Yeah, so the question is, what will print and survive being inside of a car with a lot of heat, with no deforming, by printing on a cold bed? And I think,
so the constraint is a cold bed. A lot of the nylons and stronger copolyesters require a heated bed. All right. I'm satisfied. I hope you're satisfied. The start of the show is a little bit rough, as it always is. But hey, we're here. It's live.
We were trying something new, trying to get rid of the tunneling effect, trying to make it easier for previewing what we're looking at.
Totally killed.
The monitor.
Totally killed the beginning of the show. Anyway.
Thank you all for sticking it through.
Yes, I really appreciate you, because we know we lost some people. Like, oh, here are these guys again, messing it up. Sometimes things happen like this.
David Smith, we have not tried Protopad.
What's Protopad?
I'm going to guess it's a filament.
Okay. I haven't.
Protopad? Quick Google search of that.
Yeah, Florida and all. Yeah, we're kind of obligated to test the heat now since we're in the perfect weather for testing.
Yeah.
Cool.
I'll try it out.
I think we're good.
I want to say that is all for the show.
Thank you guys so much again for joining. Tonight, we do have more stuff, new products tonight. Can't wait to see what we have in stock. That's going to be Wednesday, today, of course, at 8 p.m. Eastern Time. Before that, we have the show and tell. So if you want to showcase your projects with Lamar and Phil, you can do that. We invite you to be on the show.
Yep, we'll be there.
We'll be there this week. We're good. Okay. Tuna is also recommending check out Maker Muse, Angus, who has a lot of different filament reviews, and heat resistance in cars. Great stuff.
Check that out. Check it out.
Awesome. Well, thank you guys again for joining us. We will see you next week and later tonight. Good luck, everybody, on your maker endeavors, and we'll see you next week.
Have a great one, guys. See ya.
Bye, guys.